National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research National Research and Innovation Agency. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Thank you to those who have joined the Zoom room and official YouTube BRIN Indonesia. I hope you are all doing well and in a good health. My name is Aulia, and I will be your Master of Ceremony for the ninth of ISIBio. Ladies and gentlemen, before we begin the conference, allow me to read the guidelines of the conference. Presenters and participants are expected to join at least 30 minutes before the conference is started. All participants, presenter and non-presenters, are expected to join as much as possible all sessions in this conference. Please kindly use the virtual background provided by the official committee. Please rename your Zoom username according to the following format. For presenters, you can type code of abstract or paper underscore name underscore institutions. As the example, P4.3 underscore Senli or Paviana underscore BRIN. As for the non-presenters, you can type P underscore name underscore institutions. For example, P underscore Senli or Paviana underscore BRIN. Please mute the microphone, especially during the presentations of the keynote speakers. And in the parallel sessions, presenters should activate the camera during their presentations. Questions from all participants are delivered using the raise hand or Q&A or chat feature in Zoom room. And when Q&A or chat feature is selected, please deliver your questions according to this format. Name, institutions, the questions, or name of the speaker, and your questions. Every session will be led by a moderators, and moderators will decide which questions is to be discussed or answered. All participants, both presenters and non-presenters, should fill the list of attendees via the link given in each session. Attendees are not allowed to write opinion or information that is considered offensive, racist, or immoral in nature. An organizing committee have the full right to block or remove any attendees who breaks the above rules. Ladies and gentlemen, we will begin the conference. The Honorable Dr. Iman Hidayat, Chairman of Research Organizations for Life Sciences and Environment, BRIN. Honorable Head of Research Center for Genetic Engineering, BRIN. Head of Research Center for Applied Microbiology, BRIN. All Head of Research Center of Research Organizations for Life Sciences and Environment, BRIN. Distinguished speakers and moderators, representatives from ministries, institutions, and universities, and all distinguished guests, ladies and gentlemen. A very good morning from Jakarta. It is an honor for me to bid you all a genuine welcome to the 9th International Symposium of Innovative Bioproductions Indonesia on Biotechnology and Bioengineering 2022, or ISIBio. ISIBio itself has been held annually since 2012 and brings up the theme of strengthening for bioeconomy through applied biotechnology, bioengineering, and biodiversity. This year, ISIBio is proudly organized by Research Organizations for Life Sciences and Environment National Research and Innovation Agency, and in collaborations with Indonesian Biotechnology Consortium and ASEAN Federations of Biotechnology Indonesia. This conference also supported by PT Berkaniaga Medica and also Nutrilab. Ladies and gentlemen, in this conference, we'll gather academic scientists, researchers, research scholars to share their experience and research results on all aspects of biotechnology, bioengineering, and biodiversity. To begin the occasions, listening to the national anthem, Indonesia Raya. Please be prepared. Thank you. Ladies and gentlemen, as the next agenda, I would like to invite Dr. Nani Rahmani, Head of Steering Committee of the 9th ISIBio, to deliver a welcome speech. Dr. Nani, time and screens are yours.
Thank you for Ms. Aulia. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Excellencies, ladies and gentlemen. Welcome to the 9th International Symposium of Innovative Bioproduction Indonesia on Biotechnology and Bioengineering ISIBio 2022. The Honorable Chairman of Research Organization for Life Sciences and Environment BRIN, Dr. Iman Hidayat, the Honorable Head of Research Center in Research Organization for Life Science and Environment BRIN, the distinguished guests, keynote speakers, and invited speakers, presenters, and participants. I would like to thank everyone here today for being part of this prestigious event. As the chair of the 9th ISIBio 2020 Organizing Committee, it is a tremendous honor to see you and to welcome you for participating in this symposium. Excellencies, ladies and gentlemen, the 9th ISIBio 2022 has been held annually since 2012. This year, the 9th ISIBio is organized by Research Organization for Life Sciences and Environment, National Research and Innovation Agency BRIN. The symposium will be held from today until tomorrow, November 24th, 2022. The topic of the symposium in this year is Strengthening Bioeconomy through Applied Biotechnology, Bioengineering, and Biodiversity. The aim of this symposium are to bring together leading academic scientists, researchers, and research scholars to exchange and share this experience and research results on all aspects in biotechnology, bioengineering, and biodiversity. It's also providing participants a platform for dissemination and discussion of recent innovation and the most recent and exciting development in agriculture and forestry, bioresources and biodiversity, biorefineries and circular economy, nutraceutical and natural product, biotechnology and bioinformatics, environmental sustainability, and medical sciences. This year, we have 2 keynote speakers, 8 invited speakers from Germany, Netherlands, Italy, Thailand, Taiwan, Malaysia, and Indonesia. The 9th ISIBio 2022 is attended by 172 participants, consisting of 103 oral presentations with scientific paper published in a proceedings, 18 oral presentations only, and 51 participants. I hope you all find the assignment enjoyable and rewarding experience in this symposium. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Nani. Ladies and gentlemen, for the next, may I invite Dr. Iman Hidayat, Chairman of Research Organizations for Life Sciences and Environment BRIN, to convey an opening speech. Dr. Iman Hidayat, time is yours.
Thank you, moderator. Can you listen my voice clearly? Is it clear, my voice?
Yes.
Okay. Honorable Director of Research Center for Genetic Engineering, Dr. Rati Asmananingrum, Director of Research Center for Applied Microbiology, Dr. Ahmad Fatoni, Chair of today's symposium, Dr. Nani, thank you very much. All keynote and invited speakers, all participants joining us online or maybe offline today. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. I would like to firstly welcome all of you to the 9th International Symposium on for innovative bioproduction in Indonesia on Biotechnology and Bioengineering 2022, or we call it ISIBio 2020. This year, ISIBio event is the third one. As far as I know, we are holding this event in virtual format, except for the organizing committee for Bu Nanik dan team who present offline, I think, somewhere in the room. And therefore, I greatly appreciate it for Bu Nanik and team for your taking your time to prepare the symposium and for the successful of today's symposium. My great appreciation also for the invited and keynote speakers who will share their knowledge today with all participants, and also many thanks to all participants joining in the symposium. Ladies and gentlemen, as Bu Nanik mentioned previously, that the theme for the 2022 ISIBio is strengthening bioeconomy through applied biotechnology, bioengineering, and biodiversity. For me, the theme is interesting and challenging. Why? Because it includes the words bioeconomy. Why it is interesting? Indonesia, as all of you know, is a country with rich of biodiversity, mega biodiversity. But Indonesian economy, the main pillar of Indonesian economy is not bioeconomy. Still mining industry. Indonesia is a mega biodiversity, but Indonesia is not bio-industry country. That's why it is interesting. It is our job as a scientist, as a biotechnologist, as bioengineers. This is our job. To make it happen, Indonesia is a country with a bioeconomy as a main pillar of economy. Why this is happening? Indonesia is a mega biodiversity, but Indonesia is not a bio-industry country. Why this is happening? At least there are three main factors. The first one, many of us as a biotechnology researchers work with biotechnology, bioengineering, or biodiversity, used to work with the same discipline of science. Not used to work with other background of science. We are not used to work with scientists with the background of technique or engineering, something like that. We used to work, if I'm biologist, I work with biologists. Biotechnologists work with biotechnologists. If we do like this, with what we are doing, usually do like this, then bioeconomy is still far away to reach. Because of what? Because there is no industrial product produced from a single discipline of science. All industrial product produced from multidiscipline of sciences. That's why I encourage all of you through the symposium. From now on, please work and collaborate with other scientists with different background. It will complete your invention later on. That's the first one. The second one, as a researcher, scientist, we are also, not many among all of us here, used to work with private sectors. Why private sectors? Because they are the user of our invention. So, because they are the user, then we have to know what they need. We have to meet what they require, because they need is the demand of the people. The requirement of the industry is the requirement of the international standard of the product, something like that. Therefore, we have to, I think, we have to work with different mindset. For us who not used to work with private sector, we have to use to work with them, start to work with them from the preparation of the research project, because when we are preparing our research project to meet the demand of the industry, then the product they will use definitely. So far, the black hole or the black area, why many invention from Indonesian researchers do not use by industry, because our invention do not meet the requirement of industries. Maybe our product, our invention is very good, high standard, but do not meet the requirement. The third one is mastery the key technology. I believe that all of you are excellent researchers, but mastery the technology is different things. We have a bitter experience from pandemic COVID-19. So maybe all of you here know that since March 2020, government formed a consortium of COVID-19 researchers to produce vaccine and so on. But we failed to produce vaccine from scratch by ourselves. I mean, by ourselves, by Indonesian scientists. Indovac is not by Indonesian scientists. That's by Baylor College scientists of medicine. So we should not repeat this experience again from now on. Because what? Because in front of us, there are many challenges facing by our government, but by our people. The first one, as mentioned before, is health resilience. The second one is food security. The third one, global warming. The fourth one is environmental problems. These problems only can be solved by mastery the technology and by collaboration. So, for example, in COVID-19, the key technology is, for example, protein recombinant-based vaccine, mRNA vaccine, or virus-like particle technology, and so on. We are not mastering all of this technology. We can do, but we are not mastering. Mastery and do is different thing. We have to mastery the technology. Ladies and gentlemen, through this symposium, therefore, I would like to encourage all of you to actively discuss, sharing your knowledge, sharing your invention with other participants, to fill the gaps of your finding with other findings, something like that, to communicate so our finding become more complete and so on. I hope that you can, how can I say, you can use this event for your benefit, something like that, because without collaboration, without sharing knowledge, then it is impossible that we can develop bioeconomy, we can answer many global challenges that await now and future. Finally, before I close my remarks, as a representative of the organizing committee of the 9th ISIBio 2022, I officially open this symposium. I would like to encourage again, please use this symposium ISIBio 2022 as a place or as how can I say, as a platform for all of you to share your knowledge, your invention, to gain new knowledge from others, and to expand your network, know each other. Because with with this network, if you expand your network, and then I believe your knowledge will be better. I think that's all that my message in the symposium. Thank you very much again to the organizing committee and all participants. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Iman. Ladies and gentlemen, as was stated on the opening speech by Chairman of Research Organizations for Life Sciences and also Environment BRIN, the NINS of ISIBio is officially open. Ladies and gentlemen, next agenda is photo sessions. Please kindly activate your camera and the official committee will help to capture. And I will help to count 1, 2, 3. Please be prepared. Ready? I will count 1, 2, 3. Smile. 1, 2, 3. For the third page, 1, 2, 3. Thank you. As the limited time, the rest of the page will be captured by the official committee. For the next, we have arrived at the main agenda of today's conference, keynote and also plenary sessions that will present several speakers and also each of them will deliver interesting topics. Therefore, I would like to invite our moderator for today, Professor Dr. Diana Waturangi from University of Atmajaya. Before that, I would like to read a brief profile of her. Mrs. Diana Elizabeth Waturangi is currently a professor at Atmajaya Catholic University. As her research interests are molecular biology and microbiology, she is also an editor of Journal Microbiology and Journal of Microbiology and Biology Educations as well. She obtained her bachelor degree of biology at Bogor Agricultural University or IPB and continued her magister and doctoral degree both in microbiology at the same time and the same university. She is also awarded as an outstanding lecturer at 2010 and previously in 2009 she obtained Catholic University Association CIK Award. Ladies and gentlemen, please welcome Dr. Diana Waturangi. Dr. Diana, time is yours to lead the sessions.
Thank you very much. This morning, I'm delighted to introduce our keynote speaker. Could you please present the CV of Dr. Lily?
Hi, can you hear me?
Okay, I will read CV of Dr. Lily. Our keynote speaker is Vice Executive Director of National Energy Technology Center, National Science and Technology Development Agency, Thailand. She obtained PhD and Master in Biochemistry and Biotechnology from University of Kent at Canterbury, UK, and Bachelor from Microbiology from Chulalongkorn University, Thailand. She also received honor and award in 2013 Golden Medal Award from Seoul International Invention Fair and Golden Medal Award from Invention Exhibition of Geneva, Switzerland. And in the same year, also from an RCT Invention Award with H-index 29, and her research interests in molecular biology, microbiome, and bioeconomy. Her topic for today is the current status of bioeconomy, circular economy, and green economy for sustainable development. Ladies and gentlemen, please welcome Dr. Lily Lula Wilaichi.
Thank you very much. Can you hear me?
Yes.
Thank you very much, Dr. Diana, for a very nice introduction. And yes, even I was not, in the lab anymore, but I still working closely with our researchers and policymakers in terms of connection. So I think I appreciate what Dr. Hidayat just mentioned about, what we call horizontal collaboration. That means that how we should collaborate across all sectors to make sure that all the bioeconomy and all the production could be launched commercially. So, well, basically, I will need you to share my slide. Thank you. So share and also the ISIBio organizing committee, distinguished speakers and participants. So first of all, I have to thank the organizing team for having me here today for this event, and also thank you to Dr. Puspita to connect me to this conference as well. And I'm also thankful to Professor Handoko, President of BRIN, and his executive management team, who have always supported the ASEAN BCG network and other ASEAN activities, some of which will be described later in this talk. So today, I would like to share with you Thailand's national agenda and development of this important issue in our region. Next slide, please. Well, currently, the world faces several crises, including heavily polluted environment, overuse of natural resources without proper management, which then leads to other social problems such as migration to big city, social inequality, and poverty. To address these global challenges, Thailand has implemented the concept of bio-circular and green economy, so-called BCG, as a key to sustainable growth in the country. And we also propose this concept to our ASEAN member countries, which I will give a detail later in my talk. So back to the concept of bio-circular green economy, which is essentially integration of three, not yet, please don't change the slide yet. Sorry, this slide is really long, but all this is very important. Thank you. So these three important elements are bioeconomy, obviously, which is involved in the production of renewable biological resources and the conversion of these resources into value products. Then circular economy. It aims at reusing and recycling materials to maximize the value of limited resources. And there is a word called green economy, which determines to keep economy, society, and the environment in balance, leading to sustainable development. So Thailand put B and C and G together in the same concept. That means that we would intend to utilize science, technology, and innovation, or I call in short STI, to transform Thailand's comparative advantage in biological and cultural diversity to competitive advantage, focusing on four important economically important areas that I show in the slide below, namely food and agriculture, medical and wellness, energy, material and biochemical, and lastly, tourism and creative economy. So the BCG model will certainly enable the Sustainable Development Goals, or SDGs, through the promotion of sustainable agriculture, clean energy, and responsible consumption and production. Next slide, please. Now, how does the BCG work? The principle of BCG is value creation. This is to create value from biodiversity, bioresources, and waste. So by using STI, science, technology, and innovation, higher value of products can be created, as a pyramid shown in this slide. For example, instead of selling rice for commodity, by introducing biotechnology, special ingredients or chemical can be extracted from rice and use it in nutraceutical with higher market value. So this value creation concept can also be applied in BCG across all sectors, as shown in this slide. Next, please. Now, I would like to give examples of some important sectors in Thailand, starting with agriculture and food. Challenges that Thailand is facing in agriculture and food sector, and maybe similar to some countries in ASEAN, are the proportion between the labor force and the contribution to GDP. Excessive use of chemicals, which are mostly imported from abroad, and low production efficiency in comparison to advanced technology countries like China or the US. So in order to lower production costs and improve productivity, of course, STI should be employed. For example, new cash crops and farm animal, which are developed through plants and animal breeding research, will enable by advanced biotechnology. Also vaccine for economically important farm animals, and also premium herbal products, which can be achieved with green extraction technology, bioactive compound screening, and nano encapsulation. Next, please. An example here is collaboration among public-private people partnership, or we call 4P approach, in 5 provinces of Thailand, namely Ratchaburi, Lampang, Khon Kaen, Chanthaburi, and Phatthalung. So models have been applied to several commodities, namely sugarcane, coconut, cattle, and pig. This is in an attempt to increase 2 to 5% of economic value and environmental friendly and sustainable operation. This area have also been promoted for ecotourism. So several approaches have been applied in this area to increase this economic value, either increase the way that farmers doing their farming operation, or increase changing the way that people do the packaging, for example. And in all, we need the collaboration with the local communities as well. So those are the model that we started in Thailand, and now I believe that it's spread to all over many provinces in Thailand. Next slide, please. So as using STI, we have example at Biotech NASDA. We have the center called, National Center of Biotechnology. We call it in short Biotech. So there we have conducted microbial evaluation from culture collection, so-called TBRC, or Thailand Bioresource Research Center. So with this, we use it for agriculture, including biocontrol agent. And currently there are several fungi used as biocontrol agent, such as Beauveria, Isaria, and Paecilomyces. And this technology is systematically transferred to several farmer communities in Thailand for efficient use in several economic crops. The reason I said it is systematic transfer, because we don't just from research in the lab, we transfer directly to the local community. But of course, we have to have several media that help us in transferring process. That means maybe you can use the local university so they can interact closely to the area. We also use the Ministry of the Agriculture units that are already embedded in the communities. So with that, we can use them as a trainer to train the farmers to use this kind of technology and make it more sustainable in the area. Next, please. So the area of medical and wellness sectors, we see growth opportunity in Thailand in areas of enhancement of local cosmetic manufacturing, which are mostly SMEs, upgrading the supply of local herb, both in terms of quality and quantity, and also technology that helps extraction and purifying bioactive compounds is a focus in this case as well. For higher value products and services, we can see that the medical devices and supplies as a promising sector, along with the steady expansion of medical and wellness tourism after the pandemic. Also, the local API or active pharmaceutical ingredients and biopharma manufacturing is also in an acceleration pace in Thailand. Next, please. So in terms of energy, material, and biochemical, Thailand is one of the top producers and exporters of several agricultural commodities, but they are sold at low value. So more than 40 million tons of biomass are underutilized, yet 67% of our energy are imported. And I'm sure this situation also happened in several countries in ASEAN. So this gap presents opportunity for technology and innovation to be employed. And one of our focus is biorefinery technology that enable the conversion of biomass into energy, chemicals, and biomaterials. And this significantly raises the value of these crops and their byproducts. So the initiatives include biofuel derived from industrial waste, biomass to energy, and also biodegradable plastic. And of course, like all sectors in BCG, it needs collaboration among all players and integrative efforts of technologies. Next. So here I would like to give you some example at biotech. NASTA, again, to establish the biorefinery process, different research teams closely collaborated from utilization of biomass, enzyme discovery from microbial collection, TBRC, and also bioprocessing for product production. So one of the important factors is having infrastructure and platform that comply with various types of biomass and target products, as shown here. This is like the combination of integration of the efforts of several labs that work together to make sure that this can happen. But this will still not enough. We in the next slide, please. Next slide, please. Yes. We have to have like each step should be customized and make sure that it's optimized, and so it can be linked together more efficiently. And this shows the important factor to expedite the utilization of microbes. So what we need here is the efficient and well accessible microbial bioresources center, and I'm sure that in Indonesia you also have the very nice bioresource center in BRIN as well. And also we also here in this slide, apart from bioresource center, we also need the high throughput screening platform to efficiently evaluate microbes to make sure that it will be fast and very high throughput and very efficient. And lastly, robust production system that can be industrially scaled up. Next, please. Again, at biotech NASA, the bioprocessing platform also includes the strain development, which the new hosts have been developed, optimization process via high throughput system, and also pre-pilot scale development for genetically modified microbes that produce the target products. And of course, to make sure that all research output can directly be transferred to industry, Thai government has also invested more in the larger facility called EECI or Eastern Economic Corridor of Innovation, and with the infrastructure for pilot scale production for microbial products in Thailand. Next, please. So EECI, which has officially been launched on 16 this month, that means that's already launched, is situated at Wangjan Valley, Rayong province. And this has been the government and private partnership project with several infrastructure for BCG economy concepts, and one of which is biorefinery pilot plant, which will be fully operated in 2023. And with that, it's with several systems that can accommodate the GM production as well. GM is genetically modified organism production in this facility as well. So it's kind of the facility that really help with the BCG in action. Next, please. And of course, the last but not least important sector that I want to share today is the tourism and creative economy. So before the COVID-19, Thailand had 40 million foreign tourists coming annually, and we earn over 100 billion baht from the tourism industry. However, the revenue concentrated usually on only 8 out of 77 provinces. So that is a lot of expansion possibility there, both in terms of spreading to the secondary cities as well as targeting higher income segments. And in terms of creative economy, the estimated current value is around 10 to 12% of the GDP, mainly from handicraft and fashion. So in this sector, we see opportunity post-COVID-19 in areas like digitizing the payment system with the public payment gateway for tourism business, rehabilitated top tourism destination and secondary city destination, sustainable goods and services with the circular design and green technology, as well as the opportunity in the new target segment like agritourism, low carbon tourism, and knowledge tourism. Next, please. So in Thailand, to make sure that there is a related policy to drive BCG, 13 measures have been proposed by the BCG board that chaired by the Thai Prime Ministers, and NASDA is the secretariat. As listed on this slide, which I will not go into detail now, but we could share the slide presentation, of course, and you can look at this later. So this is like to-do list for all sectors, including all ministry, private sectors, and local communities to achieve BCG goals. Next, please. And here are some BCG activities that have already been initiated by several sectors in Thailand to support the BCG ecosystem. For example, hold on. I'm not sure, like maybe someone tried to mute me. Please don't mute me. Okay. Okay. So the first is the investment incentive provided by the BOI, such as corporate tax exemption, already given to more than 50 BCG related activities, investment promotion for the circular economy and carbon reduction. Also, the low interest loan provided by Thai commercial banks for the green businesses, and the forestry carbon project in which enterprises engaging in the forestry carbon projects on the government's land, receiving 90% share of carbon credits, and S&T infrastructure investment like ECI that I just showed you, and policy support on BCG. So here is like several things that a Thai government doing in terms of promoting the BCG in business. Next, please. So BCG in action is not only one of the key elements to directly drive the SDG or Sustainable Development Goal, but also in line with several national plans and strategy. For example, Green Growth Strategy by Japan and in several countries as well. And we also learned that, in fact, most ASEAN member states or AMS embrace the sustainable concept in their national plans. For example, Singapore with the Singapore Green Plan 2030, emphasizing on clean energy, green economy, and sustainable living. Malaysia also launched National Green Technology Policy, focusing on energy, smart building, transportation, and waste management. Indonesia has launched National Green Growth Roadmap, which features green growth opportunity in each sector, including policy and investment. And Philippines had National Climate Change Action Plan, which will be spanned until 2028. focusing on important issues like food, water, energy, and capacity building. So from this example, it is clearly shown that AMS already moved forward with this concept of a sustainable development, and this is in line with Thai's national agenda BCG, Biocircular and Green Economy that I just mentioned. So this means we, ASEAN, is heading in the same direction, which is to preserve our environment, initiate active measure to promote green growth, and using STI to convert our biodiversity into high value product that is also safe for our environment. It is therefore timely to set initiative under the same goal for ASEAN to ensure that together we could have efficient and resilient development plan, especially post-COVID-19. So the so-called ASEAN BCG network has therefore been set up. The network has already been endorsed in the ASEAN Committee on Science, Technology and Innovation, or ASEAN COSTI, and also in the ASEAN Informal Ministerial Meeting on STI in 2021. And the network itself becomes the ASEAN priority to be delivered in 2022 and 2023. Next, please. So the network is essentially a coalition of public, private, and non-governmental organizations in ASEAN with strong interest in biocircular and green economy. It aims to strengthen ASEAN capacity in research, development, and technology diffusion to enable the adoption of applicable technology for sustainable development. And the network itself will serve as a gateway to catalyze collaboration within ASEAN and other research technology demonstration, technology localization, and importantly, potential commercialization on BCG. Next, please. So we expect that this ASEAN BCG network will benefit not only just researchers and innovators, but also to business sector and policymakers, and not just in ASEAN, but the network is expected to be the part of global network and work together with others to achieve the Global Sustainable Development Goal, or SDG. Next, please. So the ASEAN BCG network planning consists of 3 phases as shown here. At the first phase, the focus is on building awareness and understanding of BCG economy among all sectors and among all ASEAN countries. So during this phase, we also call for members, and together with the development of framework for ASEAN BCG network implementation. And the following year has been devoted to capacity building and exchanging information. And the expected outcome is the capacity building program for the AMS. And the last phase will focus on collaborative project as well as co-creating mechanism among AMS, including those infrastructure sharing and capacity building among AMS and with dialogue partners. We are now moving towards phase 2, which will emphasize on capacity building among AMS. Next. So our upcoming activity is ASEAN BCG Researcher Development Program. Essentially, it aims to support the capacity building for researchers in ASEAN, especially early career researchers. So the course will include several skills important for them. For example, science communication, building the research network, and of course, understanding and driving the SDG in ASEAN. There will be 2 phases. Phase 1 will be online program. Then the phase 2 will be the on-site workshop in which the selected candidates will be sponsored by the host, which is NASDA, and the funding agency in Thailand called PMUB. So if you are interested, please scan this barcode and please register. The deadline will be by 15th of January 2023. So you still have plenty of time to join. Okay, so I think that's it. Yes, so I will stop my presentation here. And if you are interested to learn more about ASEAN BCG network or interested to join us, please contact us at aseanbcg@nasta.or.th or see more detail on our website that presented in this slide. Thank you very much, and I will be happy to answer your question. Thank you.
Thank you very much, Dr. Lula Wilaichi. This really enlightened us on the idea of Thai bioeconomy, circular and green economy, which enable sustainable development goal and also to ensure sustainable biodiversity and bioresources to protect environment and community. We will have discussion after the third speaker. So for those of the participants already come up with a question, you may start to write it down on the chat box, and please don't forget to mention the question to whom the question is going to be addressed.
Sorry, Dr. Diana.
Yes.
You might have to leave earlier due to my prior engagement. I'm not sure if you have any quick question for me.
Oh, okay. So for Dr. Lily, we can have a question and answer right now, since we have like more than 10-minute discussion. So for question, can we use a chat box or also directly using just raise your hand if any question from the audience? Okay, maybe question from me, Dr. Lily. Just would like to maybe comment from you if like this is the great idea of Thai policy, right? So just a short comment, maybe if all the countries start to use the model like BCG model, BCG system, and how powerful is program to overcome or at least to minimize the effect of climate change?
Oh, that's a very good question, because I think this BCG concept is directly want to address the climate change problem, because we don't just think about bioeconomy and competitiveness in terms of economy, but we also think about the balance in terms of environmental impact as well as a society. So that means that a lot of issue that we create or innovate, we have to think about the environment. For example, like we promote more in terms of alternative energy, not using oil and gas, but try to use the platform that produce less carbon emission, for example. So that kind of thing is actually in line with the solving the climate crisis. Yeah.
Oh, yes.
But I think the other good thing about the BCG model is not just using STI, but we also promote the collaboration among all sectors. That means that the way we do is we use the Prime Minister is follow up every 6 months on the progress of this, and with that meeting we have all the ministries, the ministers of all ministries sit together, and he follow up with all the sectors to see if there are any progresses. So everything can go very quickly. A lot of law and acts that sometimes quite slow, it can progress very quickly, and that's the way we can solve the climate challenges, because otherwise in the normal circumstance it will not happen.
Yeah, you're right. Yeah. And from Thai experience, usually this is very great idea regarding the collaboration and all of the applicable program. Who usually initiate the collaborative project? I mean, this is from research center or university or government? from your experience?
Okay, so so that if from my experience, it's a long experience. Well, there are various kind of experiences. But with the BCG model, the good thing is that we get the industry to be the part of it, and they have to invest as well, not just come and sit and then tell us what the problem, what they want, but they have to invest. So you can see like EECI that I mentioned, it's like the PTT is the largest company in Thailand, also invest in the land, invest in many infrastructure as well. So they, with that, it's kind of like make things going on, and other smaller company want to follow. So I think that's how it happens. Yeah.
Oh, thank you. And this one question from the audience. What is the main obstacle in the implementation of BCG in Thailand?
Yeah, well, there are a lot of many obstacles, of course. Like when you say you want the collaboration, but then who will be be the coordinator?
Yeah.
I think that's very important, and I think NASDA play that role in terms of being the coordinator, because we are in the center of technologies, and we also can link with everyone, both private and government. So I think the coordination of that is important, and we try to solve that by having the many structures of the committees. For example, we have 11 subcommittees take care of each subject, and these committees was chaired by the private sector, but NASDA is the secretariat. So NASDA is the secretariat of all committees, like including the one that's chaired by the prime ministers. So everything is seamlessly connected and coordinated. So I think the one thing that important to make the project, any project, successful is you need a very good coordination. I think that's my key. I mean, of course, you can save money, budget, others, but that's also the problem. But I think the coordination is the most important. If you get it right, 50% is already success.
Yeah. Thank you. Okay, Dr. Puspita.
Hi, Puspita. How are you? Nice to see
How
you.
are you? Thank you very much, Dr. Lily, for a very nice presentation. I have one question about the involvement of industries in BCGs that, maybe we have to build up together in ASEAN at least. How Thailand create the startup companies on bio-based product, to produce bio-based product. Would you share your experiences on that? Thank you very much.
Thank you. It's a very good question, and it's very difficult to answer because it's like there are many angles to it. Because when you talk about startup, you talk about technologies, right? It can start from the lab. It can be, the person who created could be the researchers, or it could create it from like SME that want the products from the lab, and then they can value created that product and have that their own company for that. So there are several kind of things, but I think the problem, not the problem, but I think the main factor that we need in every country, and also I think it's happened in Indonesia as well, is that you need a great platform, efficient platform to support your startups or SME. And in Thailand, we have also NASDA also work in terms of having a small incubation unit, having the startup system, but we also have other organizations in Thailand that promote this kind of startups as well. There are several, mechanisms. Either they give out the funding, give out the loan with the no interest, or and NASDA also share the technology with the smaller license fee. So there are several things, but of course, the startup itself, and also there are some other like investment day that they can do the pitching and like kind of have the competition, and before the competition they also teach you how to pitch and do several other things. So there are plenty of activities that help to promote that. But then I think in the end of the day, I think it's important to look at the technologies, if it's really scalable, if it's really commercially available. And I think our role as the researcher are very important. And I think we need to evaluate our own technology very well and work closely to the commercially oriented people, so they know what. I think it's similar to what Dr. Hidayat just mentioned, that need to work closely with the industry to know their mind, to know what they need, and then technology and this connected. But of course, the platform government need to support. But as a researcher, you need to have a very good technology and commercial with the commercial potential, I think. Sorry, I might not answer very quickly, but this is my idea. Yes.
Yeah. Thank you very much, Dr. Lily. Yeah, we also in BRIN, we try to work close together with industry. We open the facilities, research facility for all of the people. But it's, as you mentioned, it's still really difficult to build the startup companies on a bio-based product. Yeah, thank you very much.
Thank you. I still want to add that still, even about the startup, the coordinator is important. Sometimes you need person who understand both products and both business, and to help you with that, to follow through, to make sure that it's go to the end, like, and it succeed this goal. Otherwise, sometimes you will be in the situation where the researcher was told that, oh, okay, if you want to do this, you have to see this person, and then when you finish this, you have to see another person, and then you go to another person. It's like it never ends, and then the researchers just give up, because they said it's better to just go back and publish, right? So I think it's important to curate or develop those coordinators. And I think I have to go back to the course that I just mentioned to you. This is for the researchers or for the scientists who want to be, in the end, you can coordinate everything as well. So this ASEAN researcher program, I encourage you all to look at it, and maybe encourage your young scientists in your lab to apply, because there is an age limit. It's like 35, so not more than 35. So please encourage your younger generation to look into this course, and maybe you can be trained to be, not just a researcher, but you can be coordinating many important projects as well. Thank you.
Thank you very much.
Yeah. Thank you very much, Dr. Lily. So actually the keyword is one person who can facilitate, right? Both of the science and also management and business. Okay, have a great day, Dr. Lily.
Thank you so much. Thank you. Have a great day, everyone.
So we would like to continue for our plenary session. Okay. Our first plenary session is with the topic Waste Biorefinery Toward a Sustainable Circular Bioeconomy, a Solution to Global Issues. He's the president of International Bioprocess Association Malaysia, Director, Sustainable Food Processing Research Center, University of Nottingham, Malaysia, Co-Director, Future Food Malaysia, Professor of Biochemical Engineering, Department of Chemical and Environmental Engineering, Faculty of Science and Engineering, University of Nottingham, Malaysia. His research interest is in biochemical engineering, bioprocess engineering, microalgae technology, bioenergy, and biorefinery. He also received honor and award from Tan Sri Emeritus Professor Agustin Ong International Special Award on 2021 and on 2020 APEC Science Prize for Innovation, Research and Education Aspire Malaysia Award. So ladies and gentlemen, please welcome our plenary session speaker, Professor Paul Locke Shaw.
All right, everybody, good morning. All right, please allow me to share my screen right now. Right, this is the screen. Okay, thank you so much. Okay, so let me start with my presentation today. I given 20 minutes, so I hope that you will bear with me 20 minutes. I will try my best to finish it within the time given. So this is my first slide. This is not my last slide. Yeah, I always start with thank you. I want to thank the 9th International Symposium for Innovation Bioprocess Indonesia on Biotechnology and Bioengineering 2022. So my name is Shopal, can call me Paulo. I'm from Nottingham, Malaysia. So next slide, please. Right, so just a quick introduction about myself. I believe just how Professor Diana have mentioned about it. Yeah, so just a little bit talk about myself. Actually, currently I'm a technology advisor under this high-value, high-tech agriculture Ministry of Agriculture in Malaysia. So in this, actually, I'm the advisor whenever there is a new project, new proposal, and also new finding from this Malaysia agriculture. So I'm working on this. Also a university ranking advisor under this High Mocha University. Also a founder and president of International Bioprocess Society in Malaysia. Director of Food Processing Research Center, Nottingham, Malaysia, as well as co-director of Future Food Malaysia, because excellent. So I just got promoted to become a full professor in biochemical engineering 2019. It's a very young professor, I can say. I also visiting professor in this Wenzhou University. I got my PhD in bioprocess engineering in 2 years, as well as right after my PhD, I further another degree we call PGCG, current fellow of higher education academic, chartered chemical engineer, which is IKE, as well as next please. As well as fellow of Industry of Chemical Engineering. So I also associate scientist and professional engineer, professional technology, and corporate member of IEM. Right, so just a quick introduction about myself. As mentioned just now, our research actually covered in three areas. The first one is a bioprocess from upstream to downstream. Second is separation and purification engineering. The third one is more toward biorefinery. We call it a microalgae biorefinery. So in these three research area, I will combine it. I will share with you how we work together in the teams, yeah, in the big umbrella. So let's move to the next slide, please. So today's topic, I will share with you what is the waste biorefinery towards a sustainable circular bioeconomy, a solution to global issue. Yeah, because what I'm going to highlight today, actually we divide into 3 topics. The first topic, which is I will share with you what is microalgae first. So after microalgae, I will share with you what is biorefinery, because I believe biorefinery is very important in this circular economy. Then I will share with what is artificial intelligence. Then I will share with you the latest technology developed by our team. We call it liquid biophasing system. All right, next slide, please. Right, so first of all, what is algae? Because everybody heard about algae. Actually, algae you can get it from a lot of water, seawater, fresh water, as well as the wastewater. Right, so next slide, please. Right, so you can see algae. We have a lot of products. Yeah, a lot of it's actually algae. We can say it's a plant-based. Yeah, you can synthesize a lot of products. So just next, please. So you can see algae actually is a plant which can grow rapidly. I can say can grow very rapidly. Can grow multiple times within a day. Grow with the help of carbon dioxide, which is free of charge, because what we want is reduce carbon dioxide and with free sunlight as well as nutrient-rich water. Nutrient-rich water can be wastewater, can be seawater, and can be fresh water as well. The range of this actually can form unicellular to multicellular. Unicellular meaning that single cell, multicellular multiple cell, resize from 0.5 micrometer, which we consider microalgae, which we already use. We cannot see using our naked eyes, we only can see by our microscope. While like a macro algae, which is big algae, which can long as big as 100 meters, we call macro algae. In layman term, we call seaweed. Right, next slide, please. Right, so this is the composition of microalgae. So you can see we have required sunlight, which is free of charge. We have a level band of sunlight, yeah, especially in the area Indonesia as well as in Malaysia. Water can be wastewater, fresh water, and seawater. Inorganic carbon, which is carbon dioxide, and also NPK, which is nitrogen, phosphorus, and potassium. So the main composition in microalgae divide into three. The first one is a carbohydrate, which can have a lot of byproduct. As an example, we have bioethanol, bioprotanol, bioplastic, which is a product can get from microalgae. One protein is the main protein. I believe you heard about spirulina, right? Spirulina actually is a microalgae, which can produce a lot of protein. Can make in animal feed, can make in the biofertilizer, human nutrients. While for lipid, you can make a lot of biofuel, yeah, example biodiesel and nutraceuticals. Right. So next, please. So we cannot forget also that is a very minor things compound available in this microalgae. Example, vitamin, mineral, pigment, and also polyunsaturated fatty acids. So this is actually very important. Why I say so, because all this, right, you cannot get in most of the animal, the food that we eat, but you can get it from microalgae. Right, so next slide, please. Right, this is a short video. I'm not sure you're able to see it or not. Try to play it. You're able to play the short video here. And there is a sound actually, yeah. There's the audio. Can you play the audio as well? Maybe let me share my screen.
10,000 million by 2050?
Yes,
How
correct.
can we produce 60% more food than today in just 3 decades when the climate change and eroded soils are greatly affecting agricultural productivities? With this critical scenario, we need to find innovative solutions to help us tackle the problems. In this context, microalgae have real potential to contribute towards the sustainable development. But what do you really know about microalgae? Microalgae are microorganisms that first appeared on Earth around 3,000 millions of years ago and created the atmosphere as we know it today. They are the first organisms that performed oxygenic photosynthesis and are therefore the origin of all known plant-based life. They are the reason why we have oxygen on Earth. And still today, microalgae living in the oceans provide us with more than half of the oxygen we have. Also known as phytoplankton, they are the first link in the aquatic food chain. However, we have not paid much attention to them until now, because we now know that they have great potential to improve our lives in many ways. There are more than 60,000 different species, all of them with different biochemical composition and properties, hence with many different potential applications. Furthermore, they are highly productive, even allowing a daily harvest. They don't compete with conventional agriculture since they don't need fertile lands to be grown. And they are an inexhaustible source of biochemical richness, including proteins, omega-3 fatty acids, carbohydrates, carotenoids, polysaccharides, vitamins or phytohormones, among many others. Thanks to this composition and their biodiversity, they are a raw material with immense potential for application in many different sectors. Microalgae can be a key part of the solution because they are a source of clean, sustainable, and inexhaustible biofuels. Because they are one of the most efficient CO2 biofixation systems in the world. Because they are a novel food source cataloged as the food of the millennium by the FAO of the United Nations. But more importantly, microalgae-derived products are already playing a key role in considerably increasing productive yields in agriculture, aquaculture, and animal production. For all these reasons, we not only owe microalgae life as we know it, but also the improvement of our lives in the coming years. They are our origin, but they are also our future.
So this is a video about, actually this video is talking about the whole summary. What is microalgae? What is the composition? Why we need microalgae? So as per the video mentioned that microalgae actually is our origin, because our human exist in the world, there's microalgae already. And microalgae also our future. Why? Because microalgae can be a future food, can be a future fuel as well. Right, so let me proceed to the second topic that I will share with you, which is why microalgae biorefinery. So you can see in microrefinery, as I mentioned just now, right, we have lipid, protein, carbohydrate, and other pigment. We call it algae biomass. Because this is microalgae, we have a plant-based, we have very thick cell wall. We need to undergo a pre-treatment to break the cell wall. So what is the pre-treatment that we can apply it? We can sonification, microwave, enzymatic, hydrothermal, pulse electric, and also thermal shock. So this is a pre-treatment to break the cell wall. After breaking the cell wall, right, so you can see a carbohydrate, lipid, and protein. Undergo fermentation, you will see a lactic acid. So for lipid undergo transfiguration, you have produced glycerol and diesel. So you can see some lactic acid as well. So for protein, you can undergo some process. You will produce fertilizer, supplement, and also food product. So all these processes, right, you will involve wastewater. So for the wastewater, yeah, you can reuse it, recycle it, and for the cultivation of microalgae. So the whole process, actually, we call it microalgae biorefinery. So you can see it actually is a circular economy as well as zero waste discharge from the system. Right, next slide, please. Right, so next topic I will share with you is why we want to put artificial intelligence in the system. Because we sometimes we need to think in the positive way. Even we can see pandemic give a big impact, but pandemic also give us some benefit, which is we have no choice, cannot go to lab, so we have to learn something from home. So that's why in my team, right, we develop artificial intelligence in this microalgae biorefinery. Next slide, please. So I will share with you what is artificial intelligence. So actually, just a quick preview of artificial intelligence, actually referring to a simulation of human intelligence. So actually, we are going to train a machine that are programmed to think like a human and mimic their actions. So whatever that you think, whatever that you want to do, you can do the coding, programming, and do the simulation of it. So we call it artificial intelligence. So our team will develop this artificial intelligence in this photobioreactor, as well as to using mobile phone to do the real-time monitoring of the cultivation process, extraction. So next slide, please. So just to recap for you, what is the first industry revolution? We focus on steam engine. While next please, second revolution, we focus on electric motorized assembly line. That's where you can see a conveyor belt, a lot of conveyor belt in the industry. Third one, actually, we focus on roboting with a robot. This way you can see a robotic arm. For industry revolution, with a lot of people talking about production of system that learn and adapt the predictions. So this is we call our fourth industry. So after that, we combine everything together. We come up with a system we call a liquid biorefinery system. Actually, it's a new biorefinery techniques. So let me share with what is liquid biorefinery system. Right, next slide, please. So liquid biorefinery system actually is a liquid partitioning method of two liquid phases. So we involve a liquid system in the system. Actually, we involve two liquids together. So in our team, we successfully recover and separate magnetic compounds. So some example I can share with color pigment, protein, carbohydrate, lipid, vitamin, mineral, enzyme, nutrient, aroma, heavy metal, electric. So whatever that you mentioned, that we name it, so we can use this liquid biorefinery to do the separations. So in the next slide, I will share with you how to do this liquid biorefinery system. So in order to prepare liquid biorefinery system, actually very simple, just mixing and shaking. Just how you make coffee. I believe you coffee, coffee, creamer, sugar, and also hot water. So in this liquid biorefinery system, actually very simple. You just mix everything. There is another gradient force. In this liquid biorefinery system, there is two main factors affecting the system. The first one is the phase forming component. Just like handmade coffee, you need Arabica coffee bean or Robusta coffee bean. So you can see you can add a self-destructive agent as separation pressure agent. So the first step, actually, you put all this together. Then you can see next step is you have the phase separate. It can be a salt, sugar, iron liquid, all this. So you can see all the particular representation at the top. This will act as a separation and purification agent. Right, next slide, please. So The next thing I want to share with you are the smart extraction technology in liquid biopsy system. So what is smart extraction technology? Actually, smart things meaning that we implement the artificial intelligence system. So extraction technology actually combining upstream and downstream together. So how work in? Actually, one phase you can see is a phase forming component. Phase forming component can be either liquid, can be polymer, can be salt, can be sugar, plus a feed which is nutrient, medium, and microalgae biomass. We do the normal cultivation or process. After that, we heat it above the critical storage temperature. A lot of people will question why we need to heat it, because we deal with live organism. Heat will involve a lot of energy, but in that case, we don't heat too high. We only heat 40 to 50 degrees Celsius. We want to see the two phases. On top, after heating process, you can see top phase, you can see bioproduct and water. You just remove the water, you get your pure product. Pure product can be lipid, protein, carbohydrate, DHA, pigment, whatever that you want to extract. Bottom phase consists of phase forming component biomass, which you can recycle. So this is how we work together. We call it our bottom phase recycling system. Of course, we put the smart extractive system. So this video we can share with you how we do the simulation of simulator of cultivation and biorefinery microalgae. Yeah. So you can see from this video, right, this is a single step extraction. So we're using alga culture separation by this. So at the same time, we cultivate the microalgae. At the same time, we do the extraction of microalgae active compound from microalgae. So you can see after the harvesting system, we heat up above the critical solution temperature. You can see two phases. Yeah, two phases. Top phase, you can see all biomass. Right. So after that, after the critical solution temperature, right? So maybe 40 to 50 degrees Celsius, you see the two phases. On the biomass, we break the cell wall and we will partitioning to the bottom phase. So on top of it, right, you can see a thin layer of oil. Bottom phase, you can see a water. And this one is a biomass used to recycle. Yeah, why we claim it as smart? Because we put some sensor and we can put a Wi-Fi. This one we can monitor using our handphone. So time to time we can see the concentration of the biomass, concentration of water, and concentration of our oil layer on top. So this is why we claim it as a smart technology. Yeah, this method we already patented and we use it in mining industry. So let's proceed with waste biorefinery toward sustainable circular economy, a solution to global issue or not. Yeah, actually, yes, I can say we need to have a right combination at the right time in the right place. Yeah, because a lot of things happen around there. So I think this is our new book. I can just want to share with you. Actually, starting from 2019, we think that application is not enough to reach a wider audience. That's why we come up with books. So first book we produce, we call Bioprocess Engineering. Second book is that we have is liquid biopsy system that I will share with you. The third book actually we produce the prospect of Industry 5.0 in binary manufacturing. So you can have a look. I think the latest book that we produced this year, we call it Microalgae for Environmental Biotechnology. So this is the latest book that we produced. Actually, you can check the book in most of the bookstore and also Google Book already. Right, next slide, please. All right. So this is the next slide. I think this next slide is a lot of information, to share with you our website, as well as to keep in touch. I believe some of you may be shy to ask questions now, so you can text me or email me anytime that you want. Right. So this is my WhatsApp, my Facebook, my Talk, and my Zalo, and my WeChat as well. So this is my website. So thank you so much.
Thank you very much, Professor Shaw, on very interesting presentation on how beneficial of biorefinery of microalgae, with the emphasis on novel purification and separation using liquid bioplastic systems or circular bioeconomy. So we will have discussion after one more plenary speaker.
Thank you.
Okay, let's continue to the second plenary session. Our speaker for the second plenary session is Dr. Tony Hadibarata. He's an associate professor from Faculty of Engineering and Science, Curtin University, Malaysia, and also adjunct professor on Center for Coastal Disaster Mitigation and Rehabilitation Studies, Faculty of Fisheries and Marine Science, University of Diponegoro, Indonesia. He obtained PhD and master degree in environmental chemistry and microbiology from Ehime University, Japan, and Bachelor of Science from University of Mula Warman, Indonesia. His research interests in environmental chemistry, environmental microbiology, environmental engineering, bioremediation of toxic pollutants, water and wastewater treatment, and also in microbial enzyme with H index 37. Please welcome our plenary speaker, Dr. Tony Hadibarata.
Very good morning. Hello, can you hear me? Hello?
Yeah.
Okay. Yeah. Okay. So, very good mornings, everyone. So today, I would like to share my research about recent advance on biodegradations and bioremediations of emerging pollutants. Next slide, please. Okay. This all about waters. Yeah. In Malaysia, the situation is 90% of water supply in Malaysia is came from the rivers. Unfortunately, the pollutions of river is increasing. So until now, I have the data until 2019, still 10 polluted rivers as well as 49 slightly polluted rivers. So the pollutions is came from the point source, from the sewage treatment plants, manufacturing, agro-based industry, as well as from non-point source from the agricultural activity, plantation, and surface runoff. Next, please. Okay. The problems in the wastewater treatment system in Malaysia is only effective for the conventional pollutant, as well as the BOD, COD, THS, and so on and so on. But there is no parameters effective for the emerging contaminants removals, as we see from the tables. Most of them still showing low removings for the emerging contaminant. So it is very important to create the effective treatments, especially for the emerging contaminants. Next, please. Okay, the emerging contaminant is the pollutant. Actually, the pollutants has been detected in the water bodies. But the problem is there is no regulations. No regulation, no policy, or no environmental laws to manage or to arrange about this kind of pollutants. So in this study, I will focusing on the pH, polycyclic aromatic hydrocarbons, as well as the microplastics. If you check the publication of these two emerging contaminants, increasing year by year. Next, please. Okay, so we start from the biodiversity in Southeast Asia. As we know that Southeast Asia, or ASEAN regions, is having a highest biodiversity, including the non-wood product. We are focusing later in the non-wood products. So until 2015, 206.5 million hectares of forest cover Southeast Asia. But currently, the problem is the deforestation, increasing year by year. Here, the data, you can see the data that increasing of deforestation from 2001 until 2016, as well as the increasing of the productions forest. Next, please. Okay, this is the Sarawak. Sarawak is 37% of Malaysian regions, consisting 800,000 of protected areas, national parks, wildlife, nature reserve, and currently Sarawak has 15 national parks and open to visitor as the tourist destination in Sarawak. Okay, so here we focusing on the mushroom, the mushrooms that we want to utilize. Next, please. Okay, this is the utilization of mushrooms in biotechnology for biopulpings, for the brewings and the reproduction, as well as the fermentations. But in this study, I would like to focus on the environmental management. Environmental management. Utilize some enzymes extracted from the mushrooms, such as the lactase, the phenolxidase, lipase, peroxidase, and phytase. Next, please. Okay, maybe this is everybody already know, but the type of wood decay fungi. We have three types of fungi: white roots, brown root, and soft-root that why we use this fungi, because the similarity of the lignin, because the fungi, the component of woods can be degraded by the fungi. And we estimate that if the fungi can degrade the wood component, especially lignins, so the fungi can degrade the organic pollutants, especially the benzene rings pollutants. Next, please. There is 6 categories for the enzymes, but for the environmental remediations, only 3 playing roles: oxidoreductase, transferase, and hydrolase. So in this study, I will focusing on the oxidoreductase as well as hydrolase. Here, because these 2 enzymes is more effective for the pH as well as the microplastic. Next, please. Okay, the 3 ligninolytic enzymes consisting 3 types: the lignin peroxidase, lacase, and manganese peroxidase. Every enzymes has characteristic. For the lignins, need the peroxidase to degrade or to substrate or to oxidize the pollutants, and for lacase need the oxygens, and for the manganese peroxidase, similar with the lignins, but need the ionic manganese ions for the process. Next, please. And the lacase is one of the powerful enzymes due to the effectivity for degradations various pollutants, including the emerging contaminants. So there is 2 types of oxidations. First is direct without any addition of mediators, and the second is indirect with the additions of mediators. Of course, the 2 types oxidations can degrade the pollutants, but mediators increasing the times and the process for transformations. Next, please. Okay, we are starting from the pH. We start from the beginnings, the screenings of the mushroom. So I collect 800 for Basidiomycetes from several national park in Sarawak, Piasau, Lambir, Nia, Simalajo, and Bako. And these various forests, representing the hill mountainous tropical forest, the wetland forest, as well as the swamp forest. So the fungi is isolated using the agar mediums, and we check the effectivity or the resistances in 4 indicators. We use the poly R478, Remazole brilliant blue R, guaiacol, as well as the sinyaldazine. You can see that structure of this indicator is similar with the structure of the emerging contaminant. And then we screen based on the growing as well as the decolorization, and we identify the names of the fungi. Next, please. Okay, this is some of the pictures that collected from the forest. We collect 459 species during the wet seasons and 345 species during the dry season. So 62% is belong to the saprophytic fungi, and as well as the edible 38%, as well as the inedible. Next, please. So the identifications of the fungi was conducted by microscopic, by observing, touching, smelling, testing, microscopics by the measure the size and shape of the spore as well as the arrangement of the spores, and the finals, the molecular identifications by sequencing of PCR amplified part of the 18S RNA with the universal primer. Next, please. And the degradations process conducted like this. This is the flow, the flow of the experiments. First, the media preparations, and then culturing, incubation for several days, extraction using several solvent combination, including the separations using the column chromatography, And for the enzymes productions was identified or with the UV fish spectrophotometers with some substrates. For the detection of the metabolites is checking using the GCMS, GCMS the finals, but we have to check also the melting points, the UV fish as well as the TLC. And then we compare the results of the sample with the standards in the GCMS, or we can compare with the synthesis if we don't have the compounds, and also checking in the library of the GCMS. Next, please. Okay, this is the mechanisms. The mechanisms, if the mycelia grow, they will produce the enzyme. There is the enzymes. The enzymes will extract to the liquid culture, and liquid culture will oxidize the pollutants, the pollutants in the liquid mediums, and convert it into the simple structure of chemical. And if the simple structure is composed, the compound will be absorbed to the fungal body and degraded in the fungal body. So we compare the sample with the standards library as well as the synthesis using the UV fish, melting point, TLC, GCMS, and FTIR. Next, please. So we can see here that most of the pH, penantrans, anthracene, and pyrines, 3 rings and 4 rings pH was degraded, was degraded more than 60%. The question is the pollutants, or are the pollutants eliminated by biosources or by biotransformations? So we have to check letters. Next, please. Okay, here we can see that we found some metabolites, some metabolites from the penantrans, from the anthracenes, as well from the pyrene, and as well as the fungi that playing role in the degradations. We can see from the right columns. So we can conclude that the removal of the pH in the culture is conducted by the transformations process. Next, please. Okay, this is the pathway of the penantrans degradation. Basically, the most of the pH consisting the Bay regions and K region, and these regions, this both region is most active in compared with the other regions. So we can see here that the K regions was oxidized, by the enzymes to form depending acids, 1-hydroxynitric acids, hydroxybenzoic acid, as well as the pyrocatechol. The compounds in the brackets, between the bracket, was not identified in our culture. So this is confirming with the table previously, the table of the spectral analysis. Okay, next, please. And this is for anthracenes. Anthracenes, there is 2 role of enzyme here. The first role by lacase, to convert the anthracenes into the anthracene quinones, and finally forms the phthalic acid by the intra and extra enzymatic conversions or end-ring fissions to finally forms a benzoic acid. In the other routes, the dioxygenase and the dehydrogenase converting the anthracenes into the anthracene 1,2 diols, and finally form the benzoic acid. So unfortunately, we cannot find the both compounds between the brackets. Next, please. And this is the pyrines, similar with the previous metabolites. So there is 2 pathway. First one is phthalic acids, because the final product is the phthalic acids, as well as the salicylic acid pathway. So we can confirm that all pH has been transformed by the enzymes of the fungi collected from the forest. Next, please. Okay, so the problem is, can the treatment be applied in situ? Can the fungi or the enzymes can be implemented in situ? So, of course not. We have to was that to immobilize the enzyme, immobilize the enzymes to make sure to ensure the activity and stability still in the high performance. So there are 4 immobilization methods: cross-linking, adsorptions, covalent bindings, and entrapments or encapsulation. So each method has the advantages and limitations. And I will try to do the entrapment or encapsulation to combine the enzymes with the absorbent as well as the magnetic force. Next, please. Okay, so this is the grant from the Ministry of Higher Education about the prototype research. So we combine the enzymes with the absorbents with the magnetic powers to produce the magnesium. We call it the magnesium. Next, please. So the magnesium consisting the enzymes in the middle of the prototypes. The outer layer is adsorbent from the lignolysis waste, and the magnetic core in the inside. So we can implement the prototypes in situ, especially in the liquid or aquatic environments. So for example, if there is a crude oil contamination, so we can spray the magnesiums there, and then we can eliminate the magnesiums using the magnetic force. Next, please. So how strong the magnesium to degrade the organic pollutants? So we can see here the magnesium only cannot be effective only in the soil, because mainly focusing on the aquatic environment. Okay, next, please. The other alternative method is using enzyme dispersion. So we combine the enzymes from the specific microbes, and then we combine with the aqueous enzymes and making formulation with the ionic liquid to perform the enzymatic dispersion. So the mechanism is similar with the magnesiums, but the shape of the prototype is liquid. So we can spray in the aquatic environments, and then we can convert or we can eliminate the crude oil or oil spills in on the sea. Next, please. Next, we are focusing on microplastics. As we know that the consumptions of the plastic in ASEAN increasing year by year. But we can see here the Malaysia is highest in the ASEAN country, 16.78 kilogram per capita. Per capita. Next, please. So in order to this reason, we want to check the occurrence of the microplastics in some river in Sarawak, as well as in the commercial marine fish in some market in Miri. So we check 3 rivers. 3 rivers which we collect the water and sediments, as well as the 5 fish from markets: skipjack tuna, mackerel, sea catfish, shrimp, bivalve. Each sample 2 kilograms per market. Okay, next, please. This is the mechanisms how to analyze the water sample, the sediment sample, and commercial fish. In this study, we just only check the shape, size, and color of microplastic, as well as the functional groups. We didn't check until the mass concentrations, because we need the advanced equipments, and we don't have the equipments at the time. Next, please. So here the study, 3 rivers: Baram rivers, Miri rivers, and Nia rivers. If we compare with the other rivers in ASEAN, Indonesia and Thailand, yes, quite similar. We can compare similar. But if we check with other regions, so some rivers showing higher than the Barams, Miri, and Nia rivers. Next, please. And for the commercial marine fish, you can see that varies from the 11 items per kilograms until 20 items per kilogram. So we can compare with the other fish here. Some of them showing the high occurrence. For example, like yellowfin tuna, 5 per gram. This is per gram, not per kilograms. So if we convert to kilogram, maybe more than 500 or 5,000. Yeah. Okay, next please. Okay, this is the situations in the Baram River. Yeah, Baram River. We can see the construction of the microplastics in the Baram rivers. Yeah, fiber, pellets, fragments, films, and foam. Fragments showing the highest. Yeah, compared with the other shape of microplastic. Next, please. For size, we can see here the smallest size, 300 until 1,000 micrometer, showing the highest, because maybe the degradation or the deteriorations of the microplastics happens during the process of secreting, or extracting in the river. Next, please. And for the color, you can see the blacks and blue showing the highest, for the occurrence of microplastic in Baram rivers. Next, please. And for the Miri rivers and Niha river, this is the configurations. I will not explain in detail, but yeah, this is the configurations for the size, the color, and okay. This is the occurrence of microplastic in fish. In fish, in commercial fish, you can see here the configuration of color, and then the fragments or types, as well as the size. Next, please. This is the picture, the picture that we found from the water sediments, as well as from the commercial fish. You can see here. Next, please. Okay, this is the, when we checked the microplastics in the FTIR, so you found that the types of microplastics belong to the polyethylenes, polyethylenes, and then the polypropylenes, polyurethanes, as well as the ethylene phenyl acetates, ethylene propylene monomer, as well as the butyl bromide. So we checked based on the stretchings of the carbon and hydrogens, as well as the bending of carbon and hydrogens bond. So basically, when we check again in the sample of the fish, mostly PE, PE is showing the highest concentrations of microplastic. Okay, next please. Okay, this is the mechanisms of screening, same with the previous one,
Dr. Tony, 1 more minute, please.
Okay, okay. So this is the mechanism similar with the previous one. So, but the indicator is changing with the polyethylene, polyethylene. So we can find, or we found that the aspergillus integer is the strongest, showing 92% in 35 days, And when we check the enzymes, showing the cutinases, hydrolase, and esterase is showing the highest performance for the enzyme. Next, please. Okay, this is the mechanisms of degradation. The degradations, enzymes is attached to the surface of the polymers. And then the depolymerization happens, biofragmentation happens, become to monomers, and then the monomer will be absorbed to the cell, the internal cell, and internal cell will convert the monomers into the energy and the CO2, H2O, and or CH4 if the mechanisms of anaerobic. Next, please. When we compare with other microbes, aspergillus is showing the highest, but the problem is this is only for PE. We don't know for PP, PS, and PVC, as well as the metabolite of microplastics and the impact of aquaculture on microplastic contamination. So for the next, we will try to investigate these problems. Next, please. Next, please. Okay, this is the conclusion. The conclusion that enzymes, can make an effective sustainable strategy for the emerging contaminants degradation. I think that's all for the my presentation, because the time is over. Maybe you can show the journal. The journal maybe for the, if audience want to download the paper. This is the paper, our paper for the presentation, as well as the acknowledgement from the various grant from Malaysian government. Thank you. Thank you very much.
Thank you, Dr. Tony, for great presentation. So we will have a discussion. I would like to invite Professor Show. So for those of you who have questions, you may use chat or you can raise your hand also. So this is there's a question for Professor Show from Ibu Penny Lestari, BRIN. One is, are all microalgae species beneficial, or is there also dangerous? And the second question is, how is the quality assurance of this microalgae related to purity?
Right, thank you for the questions. Yes, yes, you're right. Yeah, some microalgae, we cannot deny that some microalgae is harmful, some microalgae is not good. Yeah, actually, microalgae can divide into two categories. The first one is beneficial algae, which can have a lot of product. Yeah, can give us some protein, carbohydrate, lipid. All this we call beneficial algae. Well, harmful algae maybe has some toxicity, maybe some ingredient that is not good for a human being. We call harmful algae. Yeah, because that's why a lot of cases, right, we need to select very carefully the algae that we consume, that we use. That's why we need to do the isolation, purification, all this to select the good algae. Yeah, just to share with you, actually in algae, right, if you grow too much algae, we call algae bloom, right? It's not good, as we can consider it as a harmful algae as well. So that's why it's a good and harmful algae, right? For your second question, actually, is relating to the purity, right? So I can say, the quality of the algae is very subjective, I can say. Yeah, because as I mentioned in my presentation, need to have a good purity of algae. If not, there are so many impurity, so many like example, the material that we don't want, the chemical that we don't want contained in the microalgae biomass, which is not good for human consumption or not good for animal as well, not good for other product as well. That's why the purity is important. Yeah, because in the traditional way we produce algae, we produce as much biomass, which we call upstream of bioprocess. So we cultivate as well as bioprocess, but in the bioprocess, right, we have a lot of ingredient purity that we don't want. That's why we need to go through a downstream processes, which is we need to do the purity extraction and also the recovery of the product from microalgae so that we can use it in any food supplement, medical, as well as a cosmetic product. So the purity will play an important role in the quality of microalgae. Thank you so much.
Okay. One question for Dr. Tony from Bapadani from BRIN. Some fungal cytochrome P450 also capable to catalyze biotransformation of PEH like oxidoreductase. However, the biotransformation product must be different because P450 cannot catalyze the formation of tyrosyl radical like oxidoreductase. Do you experience in the comparisons study of enzymatic activity of fungal oxidoreductase and for P450 against PEH? And second question is, did you identify PE degrading enzyme in Aspergillus niger? Are they PET hydroxylase?
Yes, thank you very much for the question from Dr. Danny. Basically I use here the peroxidase, yeah, because the oxidoreductase comprises three types, yeah, lactase, peroxidase, and the oxygenase, yeah, oxygenase divided by the mono and the deoxygenase. So I think P450, they will convert to not area of the K or B region. So basically in other that both area. So they will not making or not producing the quinone compound for the pH. Yeah. If you see my slide previously, most of the pH is converted to the quinone, yeah, the quinones because of the peroxidase and lactase. But for the P50, I think not making the quinones, but directly to the other pathway, maybe protocatechoic acids or the salicylic acid pathway. And for the identification of the PE degrading enzyme. Yeah, we check at the beginning the cutinase, the cutinase and hydrolase, as well as the esterase, the enzymes detected in the Aspergillus niger culture. Yeah, but we will try again. Is there any peroxidase or any oxidoreductase enzymes producing by this microbe? Yeah. Thank you.
Okay. I will give an opportunity to Ibu Yeni.
Thank you so much. Could you hear my voice?
Yes.
Okay, thank you so much. I would like to ask Professor Paulo.
Your institution, please.
My institution is from the National Agency, National Research and Innovation Agency. So I would like to ask Professor Paulo about the production of the microalgae technique. So actually, I have an experiences of using the wastewater as a growth media for the microalgae. But as we know that sometimes the wastewater have like unbalanced nutrients that can not stimulate the high production of the microalgae, So I would like to ask you if you have any experiences of using the wastewater and how to manipulate the wastewater to improve the growth of the microalgae without involving any like a chemical fertilizer or something. And the second question is about the composition of the microalgae itself, for example, like carbohydrate, protein, or liquid, or something like that. So, for example, I have an industry of the bioenergy, and I want my microalgae having a high carbohydrate, for example. Can we manipulate, like, for example, the growth condition of the microalgae so we can have the high content of the carbohydrate of our microalgae species? Thank you so much.
Right. Thank you so much, Ibu Hile, for the questions. Right. So to answer your first question, actually, I have experience in cultivate microalgae using wastewater. So what I'm trying to do actually in Malaysia, because Malaysia we have a lot of palm oil mill and fluid, we call it palme, the wastewater from palm oil mill. So we cultivate because we have 4 ponds in the palme. So we not dare to use the first pond because first pond is very concentrated, highly viscous, and the pH is very extreme. So what we do, we use the second, third, and fourth one to cultivate microalgae. The reason that we use third, fourth, and the fourth one, right? Because we think that the ingredient, the nutrient inside is suitable to grow microalgae. So in order to answer your question, actually, what we do in our lab first, actually, we characterize the wastewater conditions, right? Whether it's suitable to cultivate certain type of microalgae. Because, like example, chlorella, spirulina, different type of microalgae, right? They need different of nutrient. So what we're going to do here, we characterize of the wastewater, which water can suitable to cultivate microalgae without doing any pre-treatment and any fertilizer involved in the wastewater. So we can direct use it. So this is something that we do in our lab, right? Yeah. To your second question, actually, what is the method? What is the idea that come out from me? Actually, you want to manipulate the concentration of the active compound in the microalgae. Very subjective, I can say, because different microalgae have different ability. Different microalgae have different strength also. Yeah, some microalgae rich in protein, some algae rich in carbohydrate, some algae in lipid. So I can say what we can do is we can have some microalgae strength study. So maybe because currently we have our team developed a new consortium. We call it Algae Biotech Consortium. In this consortium, mainly we are collecting I think more than 300 strength around Asia. So maybe we can do together. We can exchange the strength. Yeah, maybe you have one strength you want to come to talk to me. Then we can share some strength with you so that you can cultivate in your site. Yeah, because the strength character is important to decide what product that you want. So let's say, example, just like you want to have a rich in carbohydrate. So maybe I can provide some strength that rich in carbohydrate. So you can try to cultivate in your site so you can produce the carbohydrate from your site. So this is something that my suggestion. Of course, some strength, right, is like I say, some strength is very need to undergo certain treatment like stress condition. So you provide a stress for them, so they will provide additional product that we want, like a hemococcus, to produce azacitidine. That is some example. So different cultivation process, different optimization process, or different condition of medium, we have different product. Right. Thank you so much.
Thank you so much.
You're welcome.
Is there any other question? Okay, I have a question for Professor Show. Does a different species of microalgae is this require specific condition of a liquid biphasic system also? And if you have a problem with contamination during simultaneous cultivation, how do you manage?
Right. Thank you, Ibu Dina, for the questions. Yeah, actually, you are right. Yeah, because you for different microalgae, you need different liquid biphasic system because in this liquid biphasic system, they have a lot of combination. They have salt, yeah, sugar. They have under liquid polymer, alcohol. So different product you want to extract. Like example, you want to extract lipid from this microalgae. You need different of under liquid, different of salt water. Because even salt, right? They have different type of salt also. So you need different combination. Yeah. So different combination will produce different product. But you do not have to worry about the combination because combination only happen one time. Meaning that you do the optimization, everything, sorry. Then at the same formula, you can produce the same product. So just like how you make coffee, you already have correct concentration of your flavor, temperature, and the creamer amount they put inside. So you continue using that formula. That is your taste already. This is your flavor already. So I can say this is a different combination. Yeah. Thank you.
Okay. Thank you.
Welcome.
And for Dr. Tony, how do you manage the production costs to produce the bioactive compound to be applicable for user or maybe other stakeholder?
Okay, yeah. Basically, we still trying to find the cheapest way to produce the mechanism, yeah, especially for the absorbents. So we can use the absorbents from the agricultural waste. So this is cheaper than we are ordering from the supplier, yeah, or from the commercial supplier. So we create the absorbents from the agricultural waste because we have equipment here to produce the activated carbons. And for the enzymes, yeah, as enzymes, especially, we try to find the best fungi that produce high units of enzymes in liter or gram. Yeah, so basically, if the productivity highest for enzyme productions as well as the cheapest for the activated carbon, then we can try to lowering the cost for production of mechanisms. For the irons, the magnetic power, I think we cannot do anything about this because this already settled, so we cannot adjust the price. Then we just adjusting the price for the activated carbons as well as the enzymes production. Yeah, thank you.
Okay, is there any other question? Okay, I think we can complete our discussion today. And I would like to conclude that it is important to develop a novel method or explore novel organism in the context to support sustainable development goal and strengthening circular bioeconomy and also green economy. Thank you very much for Dr. Tony and Professor Shaw. Have a great day, everyone. And I would like to let the MC to lead for the next session.
Yeah, thank you so much.
Thank you very much, Prof. Diana. Thank you, Prof.
Thank you.
So
nice to meet you, Tony. Yeah. Bye-bye.
Thank you to all speakers for the material given. Also, thank you for the moderator to lead the sessions. Following to the next agenda, we will have the parallel sessions consisting of 6 rooms with different topics. Allow me to read for each room. The first room will be Bioresources and Biodiversity. The second room will be Nutraceutical and Natural Products. Room 3 will be Biotechnology and Bioinformatics. Room 4 will be Medical Sciences. Room 5, Agricultural and Forestry. And Room 6 will be Environmental and Sustainability. Ladies and gentlemen, each of room will be led by moderators, and please kindly choose the room based on your interest by clicking the breakout room feature in your Zoom meeting. Thank you. While waiting for the breakout room, you can kindly take a look and also choose the room based on your interest. As you can see on the screen right now, there is 6 rooms with each topic and also led by moderators.
Recording in progress.
Halo Pak Eko. Ih,
Assalamualaikum, Ben dan Prof.
eleng aku nggak?
Healing lah, tunggu di sini.
Pak, masuk BRIN, Pak.
Iya,
Harus. Oh, di room 1, Pak Eko.
Iya, Bu.
Aku 2.4. Wit, ada Tiwit loh. Tiwit ada.
Halo Mbak Endah.
Halo. Aku rasanya senior sendiri deh.
Malu aku.
Pak Eko di bawahku. Palingan. Pak masuk mana PR peternakan kah?
Perkenalkan, Bu.
Iya.
Masih setia.
Setia sampai mati ya, Pak. Lah aku sajane ya masih loh setia lipi neng di BRIN. Masuk PR peternakan. Ini yang itu moderatornya siapa tadi ya?
Ya Bu Endang, kita masih menunggu sebentar.
Bluetooth. Aku lagi seminar sih. Aku titip nggonmu wae. Titip nggonmu ya. Iya, aku rasa metu aku mau presentasi nih ISIBio ya. Makasih. Iya, aku tak cukup rono kowe wis Lampung ya. Kono kan nganti sore toh. Aku bayarnya biasa, nanti aku transfer bilang ke Pur. Ya, suwun ya Tut. Yo yo. Yo, Assalamualaikum. Duh, kok penting. Moderator Surya Diantina. Oh, oke. Oh, Mbak Surya ya yang ini moderator ya, Mbak.
Ya, Bapak Ibu, please kindly wait for several minutes. Maybe there will be some more attendance at this room. Thank you. Okay, maybe we can start now. Dear honorable participants, welcome to the second session. My name is Surya Diantina, so I will be your moderator at this session. We are now at room 1, parallel session, with the topic Bioresource and Biodiversity. For the next 1 hour, we will have 6 presenters. I think all the presenters are now in this room. The first presenter will be Ibu Widya Pintaka Bayuputra. And then the second one is Bapak Diki Indrawan Junaidi, Ibu Tiwi Widawati, Ibu Endang Tri Margawati, Bapak Dharma Arif Nugroho, and Bapak Eko Handi Wirawan. I hope all the participants, you can please mute your microphone, and all the presenters should activate the camera during the presentation. We will have 20-minute discussion after all speakers performing their presentation. Okay, so we now move to the main. Please welcome Ibu Widya. Ibu Widya Pintaka Bayuputra. She will.
That is Mr.
Ibu Widya will be present her topic about characterization of Asian leopard cat based on mitochondrial cytochrome gene.
Yes.
Sorry, who is the manage the recording?
The organizer.
Recording in progress.
Jadi kita nggak perlu present ya. Udah di handle.
I think the organizer will perform.
Yeah.
Maybe. The organizer, please, can you please perform the video? We have, or maybe Bu Vidya.
Southern, Eastern, and Southeast of Asia. Oh, this cat. Hello, everybody. Today, I would like to present our research with the title of characterization of Asian leopard cat, Bioengineering bengalensis, based on mitochondrial cytochrome B gene as a study of meta-analysis. And the author in this study is Widya Pintaka Bayu Putra and Wirda Teti. Okay. Introduction. Leopard cat is one of Felidae family species that can be found around Asia, Southern, Eastern, and Southeast of Asia. And this cat has the conservation status of least concern. And in Southeast Asia, the habitat of leopard cat is under threat by many industrial activities like palm oil and logging production. And leopard is able to be a biological controller for rat in the plantation, so it can reducing the use of rodenticide in the plantation that dangerous for another species. And recently, the mitogenome of DNA sequence of leopard cat can be found in the GenBank database. And then the sequence can be used for creating bioinformatic analysis to determine the genetic characterization of leopard cat from many populations. Commonly, cytochrome B is one of mitochondrial DNA regions that widely used for characterization in leopard cat. And then this study was aimed to observe the genetic characterization in leopard cat based on reference sequence of CB gene that available on GenBank. And these results can be used as the additional information to support the previous studies regarding of genetic characterization of leopard cat. This is the taxonomy of the leopard cat. They have subclass of Theria, an order of carnivore, family Felidae, genus Bioengineering, species is Bioengineering bengalensis. Materials and methods, we have 48 sequence of cytochrome B gene along 915 base pair, and then we use 4 molecular softwares like BioEdit, MegaX, and ISIBio, and network for sequence analysis belonging to sequence alignment, phylogenetic tree, file-based genetic distance, genetic diversity parameters, and median joining network. This is the list of the reference sequence from GenBank that used for this study. And this is the results of the genetic diversity in the ISIBio gene of leopard cat. Total we have 45 mutation site, and we have 24 of haplotypes number, and we have haplotype diversity of 0.94, and we have nucleotide diversity of 0.01. Full statistic and Tajima's test is under negative value, and it can be suggest that sequence variation in the Bionylurus bengalensis can be affected by species expansion. And then this is the characterization of haplotype in each sequence reference of cytochrome B. Commonly, haplotype 4 is the common haplotype, and then followed by haplotype 8, and then followed by haplotype 17 and haplotype 2. This is the pairwise genetic distance among leopard cat in Indonesia. We can see that Borneo and Sumatra have relatively close according to another region of Indonesia, because in the Pleistocene period, Borneo, Sumatra are one island of Asia, and Java, Bali separated from the mainland of Asia. And then there are connective land between Borneo and Sumatra, so leopard cat can cross together between Borneo and Sumatra to build population. And then this is the phylogenetic tree of leopard cat based on ISIBio haplotype. We can see that we have two clades of leopard cat. Clade A is the mainland of Asia cat, and clade B1 and clade B2 is the clade from Sunda lineage. And then this is the network joining, median joining network among leopard cat. We have 3 clusters, and then this is the haplotype map of leopard cat. Blue point is the clade B1. B1 is the leopard cat from Java, and then clade B2 found in Sumatra and Borneo, Malaysia, and Philippines. And then clade A is the mainland lineage of leopard cat of Asia. And this is the phylogenetic tree among Felidae family. We can see that Bionylurus species is close to Leopardus marmorata, and this is Bionylurus, and this is Pardofelis marmorata. They have a similar cluster. And then this is the result of the phylogenetic tree based on the mitogenome of leopard cat. We can see we have 2 common clade. Clade A is leopard cat from mainland of Asia, and then another plate is leopard cat from Sunda. So we have the similar results. And
Thank you, Pa Widya. I'm sorry because we have strictly 10 minutes presentation, so we have to stop your presentation. And I'm sorry also for misspelling. Maybe for our participants, especially for the presenters, if you could please open your camera, that will be very much appreciated. And for the second presenters, we will have Bapak Deki Indrawan Junaidi with his topic about the leaf trait differentiate exotic native species of the same family in tropical botanical garden collection. Please welcome Bapak Deki.
Thank you for this occasion. I would like to present the result of our study by me, Deki Indrawan Junaidi, and my colleague Fatima Zahro about specific leaf area differentiate exotic from native species of the same family in tropical botanical garden collection. Invasive alien species is considered as one of the threat to native biodiversity, stated by Gorevi and Padilla and Jeske et al. 2014. The recent IPBAS report also stated that invasive alien species is one of the main cause for the native biodiversity extinction and risk. On the other hand, botanic gardens also considers as one of a pathway for exotic plant species dispersal. And this event happened in the past. Therefore, in recent time, botanic gardens need to have preventive measures, management action that may minimize the impact or the potential impact of potential invasive species arises from exotic botanic garden collection. And the option, in general, we'll have two options for these preventive measures. The first one is framework-based assessment, and the second one is trait-based assessment. This is stated by Fulong in 1999 and Dawson in 2011. The traits itself, which is considered as plant characteristic that can be measured or categorized, that indicate a particular ecophysiological phenomena of the plant, is a potential proxy that can distinguish exotic plant species that may become invasive from non-invasive. Previous studies stated that specific leaf area is a strong proxy to differentiate naturalized exotic plant species collection of botanic gardens to adjacent native ecosystem. However, taxonomical consideration in plant ecology study is essential because it will consider taxonomical factor in the multi-species functional traits data analysis and model. And this taxonomical consideration is not very much conducted in ecological studies. The aim of this study is to test whether the differentiation between specific leaf area value of native and exotic plant collection in botanical gardens is consistently exists within the identical family. So you want to know whether the exotic and the native species from the same family will have SLA differentiation. We use two families in these preliminary studies. In Cibodas Botanical Garden, we choose Lamiaceae and Malvaceae in term this due to the leaf availability for the specific leaf area sampling measurement. The study conducted in Cibodas Botanical Gardens It is located in a highland area, around 1300 up to 1450 meter above sea level, and the climate is very wet. The air humidity is very high, and the rainfall is relatively high as well. Due to the leaf availability, which is very limited, we use specific leaf area data of 9 and 6 exotic Lamiaceae and native Lamiaceae, respectively, and utilize specific leaf area of 11 exotic Malvaceae and 9 native Malvaceae. The specific leaf area data were collected based on protocol suggested by Perez et al. In 2013, and the total leaf sample is approximately more than 175 samples from all the total species sampled from 2 families. Well, the specific leaf area data collection visualization is presented in the slide. First, we collect the leaf from the tree or the small tree in the gardens in Cibodas, and then we take the photo of those leaves so we can analyze the data of the leaf photo in Imagi to measure the leaf area. And after that, we also dry these leaf samples in oven for 72 hours in 60 to 70 Celsius degree. And then after 72 hours in oven, we measure the dry leaf mass. And then the specific leaf area itself is defined as the leaf area divided by the dry leaf mass. So the specific leaf area measured in millimeter square per milligram, and leaf areas measured as millimeter square, and the dry leaf mass is in milligram. This method suggested by Perez, and we conduct this method based on the protocol suggested by Perez. And then for the data analysis of this specific leaf area data, we conduct in general, we have 2 analysis. The first one is the t-test analysis. We want to examine whether the data in general will have significantly differences or not in terms of the data distribution. We use the t-test. And then the second one is we conducted a logistic regression to check is there any tendency of differentiation between specific leaf area of the exotic and the native species from the same family, from those 2 sample families, Lamiaceae and Malvaceae. The equation is presented in the slide, where PI estimate is referred to the estimated probability that alien species I is being native or exotic. So this is basically binomial data, and then the linear regression that is included in the logistic regression. We use a specific leaf area as the explanatory variable. This is the list of the species that we use in the studies. We have the Lamiaceae species here. We have around 9 species of exotic Lamiaceae, and also we have 6 native species. We cannot have the equal number of native and exotic due to the leaf availability data in the garden, even though we may have similar species, but at some point we cannot collect representative leaf samples from the individual trees or shrubs in the garden. And this is for Malvaceae species. We have the exotic species that came from many parts of the world, including Australia, Africa, East Asia, American continent as well, and so on and so forth. And we also have the native species here. Based on the data comparison for specific leaf area of exotic Lamiaceae, from the graph we can see that in general, actually there is no significant differentiation between specific leaf area of exotic Lamiaceae and native Lamiaceae, as well as exotic Malvaceae and native Malvaceae. But we have a tendency here that the native Lamiaceae and the native Malvaceae have slightly lower specific leaf area value relative to exotic species of Lamiaceae and Malvaceae. The logistic regression show a significant result of this tendency, particularly for Malvaceae. If we can see here, for Lamiaceae, it is not significant. Maybe this is caused by a particular extreme value here for the Lamiaceae, and this may cause the regression line not significant. It's not forming a sigmoid curve as we expected beforehand. The t-tests show that there is no significant difference of SLR between native and exotic plant species.
Thank you, Bapak Deki, and sorry, we also have to stop your presentation with the limit 10 minutes presentation time. And then now for the third presenter, please welcome Ibu Tiwit Widowati. Ibu Tiwit will present her topic about comparison of indole acetic acid production between endophytics and rhizosphere bacteria of mangosteen tree. Please welcome Ibu Tiwit.
Good morning, ladies and gentlemen. Thank you for giving me the opportunity to present my research in this seminar. Let me share my screen. First of all, let us give thanks to Allah Subhanahu wa Ta'ala that we can gather at the 9th International Symposium of Innovative Bioproduction Indonesia on Biotechnology and Bioengineering 2022. Today, I will present my research entitled Comparison of Indole acetic acid Production between Endophytic and Rhizosphere Bacteria for Mangosteen. As an introduction, indole acetic acid is a major phytohormone of plants that are regulated plant development. IA production from endophytic and rhizosphere bacteria can stimulate formation of lateral root and improve plant host biomass. The plant growth promoting rhizobacteria and endophytic increase plant growth and productivity directly and indirectly. Endophytic and rhizosphere bacteria colonize the plant tissue and roots without causing a negative effect on the host plant. Endophytic and rhizosphere bacteria have been found to colonize different plants, including fruit plants, such as mangosteen. Mangosteen contains secondary metabolites such as phenolic, flavonoid, and xanthate, which are related to antioxidant properties. However, the endophytic and rhizosphere bacteria associated with mangosteen and their potential as IAA producer remains unknown. So the study aims to investigate the IAA hormone production by endophytic and endorhizospheric bacteria of mangosteen and identify the highest IAA producing bacteria. Material and method. The sample were obtained from mangosteen planting area at Cengal, Bogor. Endophytic bacteria were isolated using plant-based method, whereas specific bacteria were isolated by serial dilution. Screening for IA production using colorimetric assay. To isolate is from rhizosphere and endophytic with the highest IAA production were identified molecularly. Result and discussion. The results show that 19 bacteria isolate from rhizosphere and 9 isolate from endophytic. In the study, the bacteria from rhizosphere indicated a higher abundance than endophytic bacteria. The number of isolate from rhizosphere is higher than endophytic, influenced by soil characterization and soil nutrition and also environment condition. The roots exudate influence the presence as rhizosphere bacteria. The presence of endophytic bacteria is influenced by plant selection. About 16 isolate from rhizosphere produce IAA with a prevalence low and medium categories from 10 until 20 microgram per milli. All endophytic bacteria positive for IAA production with a low category from 0 until 10 microgram per milli. The highest of IAA of endophytic bacteria was resulted by isolate MCBN3 about 6.07 microgram per milli and isolate MCBT1 about 4.86 microgram per milli. The highest IAA of rhizosphere bacteria was produced by isolate TNM 4.1.2 about 13.74 microgram per milli and isolate TPM 3.7 about 7.26 microgram per milli. In this study, the ability of isolate to produce IAA was varied. The concentration of IAA was affected by the capability of the microorganism to synthesize tryptophan as precursor. 80% of rhizosphere microorganism isolated from different plants could produce IAA as a secondary metabolite. The secondary and extracellular metabolite of rhizosphere bacteria are higher than non-rhizosphere bacteria. This is related to the roots exudate from plants which support the activity of rhizosphere isolate. in this study show that the isolate number and IA production from rhesusphere bacteria from mangosteen was higher than endophytic bacteria. The rhesusphere soil can provide carbon, amino acid, and organic acid needed for microorganisms to obtain energy. Nutrient condition on the inner part of plant tissue is limited. Identification of the endophytic isolate MCBT1, and MCBN3 show that both isolate closely related with Pantoia agglomerans. The molecular analysis of rhesusphere isolate TPN 3.7 and TNM 4.1.2 belong to genus Serratia and Artobacter. This bacterium was commonly isolated from phyllosphere, internal tissue, and rhizosphere of the plants, and is known as an IAA producer. As conclusion, 9 endophytic and 19 rhizosphere bacteria were isolated from mangosteen plant, and they were screened for IAA hormone production. IAA concentration production by 3 endophytic and 8 rhizosphere bacteria are more than 1 microgram per milli. The highest IAA producing endophytic resulted by isolate MCBN3 and MCBT1. The highest IAA of rhizosphere bacteria was produced by isolate TNM 4.1.2 and TPM 3.7. The endophytic isolate MCBT1 and MCBN3 are identified as Pantoia agglomerans. The rhizosphere bacteria TPM 3.7 is identified as Serratia marcescens, and isolate TNM 4.1.2 is identified as Artobacter. That's my presentation. Thank you for your attention.
Thank you, Ibu Dewi, for your presentation. And next, for the fourth presenters, we will have Endang Pri Margawati. Ibu Endang will present her research topic in genetic diversity in the partial cytochrome oxidase subunit 1 genes for common kingfisher. Please welcome Ibu Endang.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon of everyone who attend this the 5th of ISIBio 2022. Thank you very much for the time to deliver part of our work. Here is our title, Genetic Diversity in the Partial Cytochrome Oxidase Subunit 1, or one gene in common kingfisher. Both is myself and Widya Pintaka Bayu Putra, who the author. Introduction: Common kingfisher or Alcedoatis distribute throughout Europe, Asia as far east as Japan, also found in Africa south of Sahara. Conservation status of kingfisher list concern according to IUCN Red List. Decreasing habitat quality and water pollution cause decline population. Common kingfisher important member of ecosystem, good indicator of freshwater community health. Here is the classification of kingfisher. Belong to class Aves, order Carassiiformes, family Alcedinidae, subfamily Alcedininae, genus Alcedo, and species Alcedoatis. As the near threatened species, conservation program kingfisher is important to prevent from extinction.
genetic diversity of kingfisher important to observe the population structure. A species population with high genetic diversity indicated low inbreeding level in the population. A cytochrome oxidase subunit 1 or CO1 gene, a part of mitochondrial region to observe the genetic divergence of species. The CO1 gene kingfisher has the length 1551 base pair encoding 516 amino acid. This gene is informed the origin of maternal lineage of species. Up to present, no any report observed the genetic diversity among common kingfisher. The study was therefore conducted to observe haplotype diversity based on mitochondrial CO1 gene with meta-analysis study. The result of the research will add information of genetic diversity in common kingfisher. Material and methods. The study using 27 CO1 gene sequences were collected from gene bank database as presented in the below table 1. For molecular software of BioEdit, MegaX, DNASP, Arlequin are used in this study to detect mutation site, phylogenetic tree, haplotype diversity, AMOVA, or analysis of molecular variants. Here the table 1 is the reference sequences we use it in this study. Result on discussion. Genetic diversity parameter was with the number of observed sequence 27 we use it, number of observed site 624, number of mutation site 8, number haplotype 7, haplotype diversity or HD was 0.63 plus minus 0.09. Nucleotide diversity of P1 is very low. Fuse VS statistic, Tajima's t-test, both are very low. The haplotype diversity in the study belong to medium category. As nested that the HD or haplotype diversity has classified as a low, medium, and high. P1 value as well as categories has 3 categories: low, medium, and high. Low nucleotide diversity in the study was caused by species expansion in the another kingfisher species of Todirampus chloris. 2 haplotype of CO gene was detected. According to the CO1 gene diversity, most common kingfisher, 59% were classified into haplotype 1. Haplotype 1 may be described as the common ancestral for common kingfisher. 8 mutation sites of CO1 gene kingfisher were detected as polymorphic site assigned by 2 nucleotide of each mutation site. But in Todirampus chloris, 9 mutation sites were detected in CO1 gene as a Geber et al. Report. Now inspired by genetic distance, phylogenetic tree, clade distribution, and AMOVA. By genetic distance was found range between 0.002 until 0.09. Low value or D genetic distance means close genetic relation due to near geographical distance. Here is a phylogenetic tree that also is grouped into Cyanopectus and Corytornis leucogaster. But the O1 gene, also the artist as reported by Luxon, has close genetic relationship to mega cereal and cerealine species. Yes, Amova revealed that about 37% of the geographical factor was affected by the sequence variation of common kingfisher. There are no significant natural barriers between Europe and Asia region. It influenced by the migration and distribution of common kingfisher. Based on the clade distribution in the study, we found two clade A and B. Clade A consisted haplotype 1, haplotype 6, haplotype 2, and 3, while clade B consisted haplotype 4, haplotype 5, and 7. Here is the distribution of common kingfisher. Most of common kingfisher in the room were classified in the clade A, determined in Philippines, Japan, South Korea, China, Mongolia, Russia, Turkey, and Cyprus. Clade A was determined in the common kingfisher for Turkey, Kazakhstan, Sweden, and Norway, signed with the blue one. Conclusion, the JO1 gene of common kingfisher has high haplotype diversity with 8 mutation point. Total of 7 haplotype with 2 clades were detected in the JO1 gene of common kingfisher. Haplotype 1 in clade 1 were detected in the most common kingfisher in this study. Thank you very much.
Thank you, Ibu Endang. I just know that kingfisher is a bird instead of the fish. Bapak Ibu, we already have 4 speakers here. So if you have any question, you can start to write your question at the chat box, or you can raise your hand. So now we move to the last 2 presenters. First, Bapak Dharma Arif Nugroho will present his research about crab biodiversity from coastal region of Moa Island, Southwest Maluku, Indonesia. Please welcome Bapak Dharma.
Hello everyone. Today I would like to present my research. The title of my research is Crab Diversity from Coastal Region of Moa Island, Southwest Maluku, Indonesia. My name is Dharma Arif Nugroho from Research Center for Biosystematic and Evolution, National Research and Innovation Agency. Let me start from introduction. The order decapod is estimated up to 10,000 species worldwide, but the crabs or Brachyura is estimated at 443 species in Indonesia. This data from Suharsono 2014. Moa Island is one of the outermost islands of Indonesia. Moa Island is located in the south of Banda Sea and north of the Timor Sea. The crab biodiversity of small island is not well documented. So, is it important to do as a basis for information on biodiversity of Indonesia? The aim of this research are to study crab biodiversity and collect data on the different type of crab. Let's start the methods. The study was undertaken in Moa Island, Moluccas. Here is map of Moa Island. We can see Moa Island in the south, a small island. Research was conducted from 18 to 25 September 2019 at 6 sampling locations. The locations are MOA1, MOA2, MOA3, MOA4, MOA5, and MOA6. The next, we also using quadratic transect and the purposive random sampling method to obtain crab species. Here is process collecting. After that, we sorting, cleaning and labeling, then photographing. After photograph taken, we preserve the sample. This is example of crab that have we take photograph. After that, we identify all the sample in the laboratory. Data were analyzed using Shannon Weaver diversity and Simpson index. Hierarchical cluster analysis was used to assess the similarity of crab biodiversity between the sampling location. Result and discussion. Here is a composition of number individual species, genus, and family in each sampling location. We found total crab is about 160 individual, 33 species, 28 genera, and 14 families. Here is with the green mark is the highest. MOA1 and MOA2 is dominant. Then the lowest is MOA3 for individual and MOA6 for species, genus, and family. Is only found lowest than other station. For crab diversity, we analyze the diversity index, Simpson index, and dominance index from sampling location. Here, index from MOA1 is highest than other location, and the red mark MOA5 is the lowest index rather than other location. The value of diversity index is about between 1 and 3, is the meaning the diversity at sampling location tend to be low and moderate. Then the Simpson index is linear with diversity index. The dominance index is opposite with diversity index. This is a comparison of the number of crab species and the Shannon index from other research in Indonesia. This is a number of species and Shannon index from this research shown more high rather than other result of other research. We also analyze recursive similarity. This is a result of dendrogram of Bray-Curtis single linkage cluster analysis showing crab grouping of sampling location. Most of the sampling locations are less than 50% similar. Each sampling location has differences in the term of diversity of crab species. MOA 2 and MOA 5 have habitat similarity up to 6%. For conclusion, there are 14 families, 28 genera, 33 species, and 160 individual crab has been collected from MOA Island. MOA 1 and MOA 2 are the rich sampling locations that have 14 species. The highest diversity index is 2.39 at MOA 1, and the lowest was 1.51 at MOA 5. That's all for me. Thank you for the attention.
Thank you, Bapak Dharma. Dear honorable participants, now we have the last presenters at this session, Bapak Eko Handiwirawan. Bapak Eko Handiwirawan will present about characterization and differentiation of three sheep breeds which have a genetic relationship. Please welcome Bapak Eko.
Thank you, the committee who gave me the opportunity to present my research. Assalamualaikum warahmatullahi wabarakatuh. On behalf of my research team, allow me to share information about my research. My research title is Phenotype, Diversity, and its use to distinguish three genetically related sheep breeds. The paper was written by me, Eko Handiwirawan, Sari Yanti Hayanti, Destias Namoti, and Ismet Inaunu. Background the research. Import of Saint Croix sheep and Barbados frozen salmon sheep has been carried out in a breeding program to improve local sheep productivity. The birth of exotic breed were crossed with Sumatra local sheep. We mention SL in the next to produce the Sumatra composite SC and Barbados black belly cross BC, which can adapt to Indonesian environment and have better productivity. FAO define of breed is a group of domestic livestock with external characteristics that can be defined and identified. This definition could be used to distinguish a group of animals from other groups within the same species. SC, BC, and SL sheep are three breeds of sheep with a particular genetic composition and therefore have specific morphological characteristics. The three breeds are genetically related, so they have almost the same phenotype and it can be not easy to distinguish. This study aims to characterize the phenotype and use phenotype diversity to distinguish three genetically related sheep breeds based on the diversity of their qualitative characteristics. Materials and methods. The study used three breeds of sheep, namely Sumatra composite, Barbados black belly cross, and Sumatra local sheep. A total of 246 heads adult sheep, male and female, was used, which consisted of 53 BC, 95 SC, and 98 SL. 5 qualitative traits were observed, namely presence of horns, 2 criteria, dominant coat color, 5 criteria, color pattern, 4 criteria, stripe colors, 13 criteria, stripe distribution, 5 criteria. The application of SAS was used to calculate the frequency of each qualitative trait and then multiple correspondence analysis to obtain traits associated with a particular sheep breed and distinguish it from other breeds. This is the result of research. In table, we can see about the presence of horns in BC, ST, and SLC. Horns were only owned by a ram with different proportion among breeds. SL and SC ram had the same horn and poult ratio, and the horn and poult ratio for BC rams was higher than SL and SC. This table shows percentage of dominant coat color on BC, SC, and SLC. Dominant coat color of BC, SC, and SL rams is dark brown, white, and brown respectively, whereas the dominant coat color of BC, SC, and SLU is brown, white, and white respectively. Among the three breeds, BC and SCUs have more various colors compared to SLUs. This is a table of coat color pattern. Ram coat color pattern in three breeds were generally a mixture of two colors. U in three breeds has a more varied color pattern than ram. SC and SLU have a more varied pattern that is single color, a mixture of 2, 3, and 4 colors, while BC only has a single color pattern, a mixed 2 and 3 colors. BC and SCUs generally have a pattern of mix of 2 colors, while the SLU is usually single color. The table shows the color stripe on ram and U of three breeds. The stripe color of the SL ram was less variation compared to BC ram as well as SC ram. Compared to rams, U's have a more stripe color pattern variation. The SAU have 9 stripe color variation, SLUs have 7 stripe variation, and BC's U's have only 6 stripe color variation. The stripe distribution BC, SC, and SLC was shown in the table. Among three breeds, SL ram has more variation of stripe distribution, whereas SC ram has 2 stripe distribution variation. And finally, the BC ram has less percentage of colored stripe. The stripe distribution of SC and SLUs have 5 types of stripe distribution, whereas the BCU has 4 types of stripe distribution. It can be seen in figure that every ram is located in a separate quadrant. SL ram are found in quadrant 3 and separated by BC ram in quadrant 4 and SC ram in quadrant 2. This figure indicates that the 3 breeds of ram were different and have specific characteristics that distinguish among breeds. In the figure, also we can see that SL, SC, and BC ram are closely related to some qualitative trait characteristic. In the next figure, we can see that SCU has light in quadrant 1, SLU in quadrant 3, and BCU in quadrant 4. Like the ram, it means that the U can be distinguished by a characteristic of qualitative traits among 3 breeds. Conclusions. From the research, it can be concluded, firstly, qualitative characteristic can be used to distinguish genetically related sheep breeds. In the second, SL ram related to brown dominant coat color, SC ram associated with white dominant coat color, while BC ram was related to white color stripe distribution higher than 20 to 30%, and stripe color of mixed 2 colors as well as some other color characteristics. And the last, SLU was associated with brown dominant coat color, single color pattern. BCU was related to dark brown dominant coat color, black color stripes, with a percentage of higher than 10 to 20%, and some other characteristic. SAU was closely related to brown and brown black stripe distribution 1 to 10% and higher than 40 to 50%. Mixed three colors and some other characteristic. I think that's all. I hope all the information can be useful. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Eko. Bapak Ibu, now we are move to the discussion section. I believe that our presenters have a very interesting research in the plant and animal topics. So if you have a question, you can use the raise hand option, or you can write your question at the chat box, please. Okay, maybe I will start with one question for it. Ibu Tiwit, from your research, you mentioned that there are some endophytic and rhizosphere bacteria has high indole acetic acids. So maybe from your results, you can explain, or maybe you can have a suggestion what is the implication for the future research from your research. Thank you.
Yeah, thank you, Ibu Surya, for your question. From our research, I categorize or divided the IAA production divided two categories, low and medium or moderate. From low categorization, from 1 until 10 microgram per milli, and from medium categorization from 10 until 20 microgram per milli. And for the future, maybe from the IA production, we can use the bacteria as a plant growth promoter for plant growth, and also the another ability such as biocontrol or and I mean another capability such as for nitrogen fixing or phosphate solubilization. But in the research, I only focus on IA production. But just information, if we get a high IA production, sometimes the capability to promote the plant growth is still limited, because sometimes the IA inhibit plant growth and the trigger the ethylene synthesis. It's my answer.
Thank you, Ibu Widya. Ibu Tiwit, sorry. Thank you, Ibu Tiwit. Ibu, due to the time restriction, I think we have to close this session. Thank you for your attendance and participation. Shall we now return to the main room for the next agenda? Once again, thank you and have a nice day. You can leave this room and come back to the main room. Thank you.
Thank you, Mbak
Thank you,
Surya.
Surya.
Thank you very much for the
Thank you for
Pak Dharma di Grab ya kerja PRBB Pak, PRBE ya.
ya Bu.
Oh ya. Dari LIPI dulunya kan?
Iya.
Oh ya, bareng Bu Desi. Iya Desi.
Iya.
Oke. Ada yang minat dari Malaysia loh Pak. Grab. Oke, live ya. Pak Eko, see you later.
Recording in progress. Bioengineering and Biodiversity is one of the most dynamic and innovative companies within the BERCA Group. The BERCA Group consists of over 35 operating companies in over many industries, including technology, infrastructure, and engineering. Bioengineering and Biodiversity has been in business for over 17 years and has established itself as the major player in the research and the chemical analysis industries. Its customers include many bodies in the government sector, as well as large corporate entities. And its industries include food research, agriculture, petroleum, chemical, environment, and clinical research. We believe that Bioengineering and Biodiversity is very well suited to meet with all stakeholders to support the quality of life and to improve it in Indonesia. We fully support Bioengineering and Biodiversity to meet with all stakeholders and form partnerships to improve the quality of life of people in Indonesia.
Distinguished guests, ladies and gentlemen, welcome back to the main room. How was the panel sessions, Bapak, Ibu, and also ladies and gentlemen? We hope it was very nice sessions. And now we will have a break for approximately 1 hour and 5 minutes. Please kindly remain in the Zoom meeting or back to the Zoom meeting at 1:30 p.m. Jakarta time. Once again, we will have a break for approximately 1 hour and 5 minutes. Please kindly back to the Zoom meeting or remain at the Zoom meeting And we will start the next agenda at 1:30 p.m. Jakarta time. Thank you.